Hello everyone! With the rise of Qwen-Image and Nano Banana, many people are paying attention to multimodal models for image editing. Recently, a new model has emerged. This is USO from ByteDance. This model primarily focuses on subject referencing generation and style referencing generation. Actually, from a functional perspective, this model is not significantly different from the other two models. For example, we can provide a reference image and then maintain the consistency of a person, generating that person in different scenarios. Additionally, we can provide a style reference image to generate effects in various styles. From the project's GitHub website and its paper, the results we've seen are quite good. Some even jokingly call USO an open-source nano banana, or simply state that it is currently the best open-source model for consistency. So, how well does it actually perform? Let's test it out below. First, a word of caution. This technology looks quite magical, but when you actually use it, you'll find that it's just a lure. This model is primarily built using decoupled learning and reward learning mechanisms. For installation, please note, as I mentioned earlier, its form of expression is flux plus a lure. Therefore, you basically have two ways to deploy it. The first way is to deploy the complete FP16 flux model. In this case, the VRAM usage will be relatively large. Second, if you want to deploy this model on a consumer-grade graphics card, everyone should try to use the FP8 model. This way, we can complete the entire deployment and operation under 16 GB of ROM. Next, let's look at the overall installation. You can refer to this section for the installation commands. Actually, it's a relatively standard procedure. We can divide the entire installation into three parts. The first is the installation of the overall environment. The second is model download. The third is performing inference using commands. For inference, we can use either command line interface or our GUI, which is the web interface. The first step of installation is to check the basic environment requirements. For example, here we can see that the Python environment requirement is greater than 3.10 and less than 3.12. Additionally, the PyTorch version is 2.4.0. You must clarify these two basic environment requirements. Therefore, before installing other environments, you must ensure the basic environment is correctly set up. First, we check the current Python environment using Python v, and my current Python environment is 3.10, which is fine. Next, we can find our PyTorch version using piplist greptorch. My current PyTorch version is 2.4.0, which also meets the requirements. If you need to install PyTorch 2.4.0, there are several CUDA versions you can choose from. Here, I chose CUDA 12.4. Alright, next, we'll proceed with the standard installation process. First, I'll clone the entire repository using git clone. After that, we will install all the dependency packages using pip install rrequirements.txt. At this point, the basic installation is complete. Next, we can download the model. For model download, first, please note that there's a file called example.env. These are mainly environment variables. Please copy it and rename it to .env file. Additionally, you need to set an additional environment variable called hf_token. This is for using Hugging Face tokens. The setup method is very simple. First, you need to log in to our Hugging Face account. After logging in, you can click on your avatar. There's an option called Access Tokens. Click on it. You can create a token by clicking Create. Just create a read token. That's enough. I won't proceed further here. You should set this token to the environment variable. Next, we need to install Hugging Face_hub, primarily for downloading our corresponding models. Then, execute the downloader in the waits directory. That's it. The model download process will depend entirely on your network status. Currently, my USO is deployed in the USO folder within the workspace directory, which is the root directory. This is where we cloned the entire downloaded file using git clone. Now, we're going to start it up. I haven't set up auto start for everyone, and here's why. Let's now show you the startup process. It looks like this. You can open the GitHub directory. Regarding startup, you'll find there's a suggested command here. Execute app.py with Python. Then, here, we need to specify offload. This is similar to the block swapping technique we discussed before, using CPU and GPU swapping to achieve the goal of reducing VRM usage. Additionally, here we use FP8. It says name flux dev p8. Please note, if you have downloaded the FP8 version yourself, you can put it here. If you haven't downloaded it, that's fine too. Now let's execute it. Take a look at the effect. Copy and paste. We'll start it directly. Before starting, please note that I made a slight modification to this app.py file. The modification primarily involves adding a server_name argument here. If you don't add it, the Gradio web page you launch will only be accessible locally. We want it to listen on external network ports. Therefore, you need to add this. Remember to make this change when you're doing it. Now, let's start it. Enter. Some might ask, what if I haven't downloaded the FP8 model? What to do then? It will convert the FP16 model to FP8. Because when we downloaded the model earlier, we downloaded the original FP16 version. Now, let's start it up. You'll find that the startup time will be quite long. This is why I haven't set up auto start for everyone. If I did auto start, you might wonder, why isn't it starting? You might wait 3 minutes, and it still hasn't started. You might worry if there's an issue with the server. Actually, no, this process just takes a while. There's a message here about transformer. You don't need to worry about it. Just let it continue. Then we see the second prompt message. It's initializing the V. Furthermore, it says that if you want to use the FP8 format now, it will directly flatten the current FP16 model into an FP8 model. Then you'll see a message like this, running on local URL 0.0.0.0, port is 7860. We'll open a new page, and the port is 7860. Note that the colon here is an English half-width colon. After opening it, let's first look at what it can do. There's a simple description here stating that this model was trained at a resolution of 1024 by 1024. It supports 3 types of applications. The first type is where we upload a content image, which is the reference subject. The second is where we can upload a style image. The third type is where both can be uploaded. So, it basically covers 2 tasks, style transfer and subject consistency generation. Let's start with the simplest example. Let's pick one. For instance, when you click on this example, it will populate the content above. Here's a subject image of a cartoon little girl. Then, I want her to be riding a bicycle on the street. Below are some advanced configurations. For example, width and height. You can set these yourself. The default is 1024. Then, let's generate it. Everyone, take a look. The subject consistency is still pretty good. Of course, with a cartoon image, we might not see much. Let's actually do a test. For example, let's upload an image now. This is a portrait of an East Asian beauty. Then, let's write here, the woman is reading a book. After that, let's generate it again. And let's see how the consistency turns out. Everyone, take a look. It's still pretty good, isn't it? Let's adjust the seed to -1. -1 is random. Let's change our prompt to this. A girl squatting in a garden, gazing at a bouquet of flowers. Now let's generate it again and see the effect. At this point, we'll find that the consistency is actually not as strong, right? The composition here is also problematic. Let's try another prompt below. For instance, this one. The woman is giving a passionate speech. Then, let's generate it. I think the consistency is acceptable, but the image quality doesn't seem particularly high. Now, let's try another one. The woman is drinking tea. Let's generate it again. This one is okay. Through these examples, everyone will find that the greater the change in viewpoint, the worse the consistency. For example, if we try riding a bicycle, the effect might be even worse. Let's try it. Let's take another look. I feel that the character's consistency is even worse. Perhaps my prompt was problematic. Instead of girl, I should have used woman. Let's try again. Let's take another look. I think the overall proportions will be problematic. So, the closer the viewpoint is to your reference, the better the effect. If you zoom out, the consistency will be very poor. Finally, let's try a prompt saying, the woman is gazing at a bouquet of flowers in a flower shop. Everyone, take a look. This effect will be better, because her viewpoint will be closer to this. Therefore, I believe its consistency generation cannot be compared with Nano Banana. Furthermore, there's also a gap compared to Qwen-Image. So, USO's ability for character consistency is indeed a bit exaggerated. Next, let's look at its style transfer by reference. I'll now upload a reference image for style. This is a style similar to a pencil sketch. We won't change anything else. Let's generate it again. Everyone, take a look. This effect is absolutely fantastic, isn't it? So, I think its style transfer effect is quite good. This is a Chinese green landscape painting. Let's see how its generated effect looks. This feeling is also correct. No problem. It's just that the character isn't as beautiful, right? Let's try a style similar to ink wash landscape painting. I think this transformed style is quite good. Let's try a more common one then, a Japanese anime style. Looking at this style, I think it's also pretty good. I think the style transfer is still commendable. Furthermore, it supports a third type of style, which means you can have an effect that mixes two styles. For example, let's now add a pencil sketch style. Then I'll notice some pencil lines within it. This isn't particularly obvious. Let's change the third image to Van Gogh's Starry Night. And let's change this one to a pencil sketch. The difference between these two is quite significant, right? Let's try it, and this will be clearer. Notice, it has both the pencil sketch style and the overall characteristics of Van Gogh's Starry Night. So, they can be blended together. This concludes the testing content we wanted to show you. My final conclusion is this. For consistency, it scores about 70 points, and style referencing might be more unique with better overall performance. Everyone can try it out for yourselves. I believe this model may still have significant value in specific applications. Alright, that's all for today. Follow me to become someone who understands AI.